make sure you have your name and the date at the top. If you want to write today's date, that's fine. If you want to write yesterday's date, that's also fine. Make sure that you always have it filled out at the start of class. Yeah, sign the bottom really quick, so that way you know what to do whenever we do something in lab. You know and you understand. Basically, to not be stupid. That's the summed up version of everything. Just to not be stupid, follow directions, use good common sense as you're going throughout it. So, Jamie and Quentin, please email me a picture of both sides, front and back, as soon as you can.
Courtney's?
Yeah, but this should be hopefully like a good, easy 100, hopefully. Unless you just did not follow along, you did not pay attention. This should be like a good, nice, free 100 at the start of the chemistry class.
Have you ever had anyone fail that?
I've had people forget to fill out like the back page, like not this particular one because this is the first one. Most students are like hyper aware over what they're supposed to be doing. But I had students in other ones forget, oh, there's a back page. And it's one of those, well, sorry, there goes about half your points then. Alright, Trish, you want the blue or red?
I'll go. What do you want? Blue. I'll go red.
Okay. So again, only throw 2 darts. I just don't feel like just giving you just 2.
We're only doing 2?
Yeah, just 2 at a time. So that way, first is your practice shot. Second one is to help kind of get you counted for it. Alright, name we'll start with. Well, since easy pick colors, we'll go with this. Name something you do or something you wear to keep yourself safe during lab. There are 3 things specifically talked about.
Goggles,
Good job.
lab coat or
Okay, that works.
apron, and gloves.
Good job. Alright, so choose those. Keep track of your own points because I don't want to do math. Alright, again, this turns into too long. We'll have to stop.
Right, that's fine, right?
You can go up to this desk and I'm going to move it so that way not so much on you. That's just unfortunate.
It's still
It's
19.
where the metal
But
hits.
it's still 19.
Yeah. Alright, 19. Alright. What? Alright, should you ever eat and drink in the lab? Ethan?
No.
Nope. Alright, no, start. That was it.
We had normal homework too, didn't we?
Yeah, you did. I'll go over that in a second. Good job. Start your points.
I don't know what it is.
You may keep the 5 or rethrow. Alright. What is, let's see, when should you read your lab instructions?
Before.
Yeah,
Right, no,
before you-
well, like the night before, you prepare the night before, know all of it, but then right before you start your lab, read it again so you refresh.
That's best. So basically, just read it before you come to class. Alright.
I don't read it like.
Yeah, don't be like, Miss Morse, what am I doing? Don't have time.
Ouch.
That's better. That's a real
Kobe.
bummer. I'm sorry.
That's what happened with
Alright,
helicopter.
whenever you're diluting an acid, do you pour acid to water or water to acid?
Water.
Acid
No.
water. So do I get it?
The video.
No, wait,
he,
don't help him.
his
You just
cat-
change the answer.
He had that bottle with the hydrochloric acid
Alright.
in the water.
So you're going from acid to water. Yes, that's
I
it.
wanted the acid first, so.
He changed his answer. Just wait for him to get committed to his sponsor because he said wait, and then he changed it. So you have to change it before, careful, before I answer. You may rethrow or keep the 3.
Why is he?
Where'd it go?
Where's the free throw for? Like you get one.
If you get it on the line to where you can't, to where I can't tell clearly which one it is.
That's way far.
I couldn't see it because of the floor.
Yeah, no, it's blended.
You shoot it again?
Yeah.
Alright. Should have the 3.
Wait, you don't get answer your question yet. Alright, so what should you do with leftover chemicals? Should you put them back in the bottle or do you throw them away?
You should ask people in the lab if they need any, or you should post it in a chemical safe container.
Yep, so don't put them back in the pure bottle because you will mess up your dilutions.
Kobe.
There you go. So it doesn't fall. 17.
My precision and accuracy is insane.
Alright, let's see.
17.
Should you ever taste the chemical, even if you think this is the
No.
same chemical? No, never test it. Ever. water.
Unless it's hydrochloric
Even if
acid.
it tastes like cherries.
Hey.
18, bruh.
18.
Alright. If you have to smell a chemical, what should you do to try to get it towards your face?
Waft it to
Good
your
stuff. So yes, you cut your hand off. Don't just go, what's it smell like? No.
Then you're gonna get nail polish.
Yeah. Bad experiences. Hurts.
What?
I'm sorry. I'm sorry.
It didn't even try to stick.
Maybe Ethan knew a secret whenever he picked the blue ones.
It didn't even try to stick.
I'm sorry. Alright, should you just dump all your liquid chemicals down the sink?
No.
No, particularly this sink because there's one container that it's hooked up to and you will just mix all my chemicals together. Don't do that.
There's chemicals already in there.
No, but there's one container that holds, so basically that this runs to. So sometimes, sometimes you can put like an acid down it, but then you can't put like a diluted baking soda down there with it
Oh,
because it'll react inside my canister and start like exploding inside under the sink. So yeah, don't think something. Alright, going over more of your terms now for it, because that was your major ideas from lab. What is the metric unit for mass?
Start with a mass. Start with a what's her?
You can go with K or G.
K or G? Oh, gram.
Yep, gram or kilogram. So that's the metric unit for mass. I'm very sorry. I'm sorry. You were so
Get on my
excited.
face.
You were so excited to play this game too. Alright, what is the metric unit for length?
Length.
Length.
Meter.
Meter.
Grit.
1.
Five.
Basically. Alright, what is the metric unit for, I'm missing one.
You're missing
The volume, that's what it is, volume. Yep. At least it's stuck.
Yeah, for real.
Alright.
Hey, now it's on it though.
It's on 4 right here.
Yep.
Precision.
So at least you have 4.
Stop.
Alright, what is the quantity of matter in an object? What term do we use to describe that? How much matter is in an object?
Like compactness.
Not compact, just how much is there?
Mass.
Mass.
It's what you do.
Good job, Ethan.
We'll study on how to
This
throw
is
it out.
one class you really do well. U.S. history too, but you do have to study for chemistry and for U.S. history. You should
That's
probably
what I
realize.
need to figure out. Like, if I want to pass my hard stuff.
I didn't like so really not.
Yeah, but this year you should. What
Yeah, I
is the
never
force
figured
of gravity on an object?
What's it got? What? The force of arms. I don't know. Force of
Yeah. So what do you call whenever gravity's pulling down on you? Like we have.
force?
Okay, there's another term we use to describe that. So if you have more mass than gravity, we say is pulling harder on you. Technically, no, but
What was it? So
W.
W?
Yeah, I'm trying to describe it, but I don't want to give. Yeah, weight. So it's
Bruh.
like how much of it, like how much or how hard gravity's pulling down on you.
Cool.
I'm done.
It's
No,
depressing.
I'm going out the window.
No, wait, hang on. Can't go too long. Alright, right throw. I'm sorry. I'm very sorry. Alright, what refers to the compactness of matter in an object?
Density.
That's density. I think we kind of know who's going to win at this point, but I'm
No,
sorry.
we don't.
Just
I've
keep
gotten all
going.
big numbers.
Okay,
Never mind.
15.
15. Alright, what refers to how much space matter takes up? Volume.
Kobe.
At least you get the little circle.
Kobe.
Hey, 9.
Nine
Alright.
the line. Can I reshoot? No.
I would say it's 9. I think it's 9. Alright, now we're gonna find density. So rho, I know it looks like a P. How do you find, let's finish the equation. Let's do it with that, so
MG.
and then Jimmy, Clinton.
M over V.
Good job. So M stands for?
Mass.
Good job. Over.
Volume.
Good job. Just making sure. That's the bummer.
It's just
No, it's not on it.
It's crazy
It's not
because
on it.
when he misses, but when he hits,
It sticks.
it doesn't slide.
I'm sorry. Alright, if you're finding the temperature of Celsius and you're going from Fahrenheit, what's the equation?
Going to Fahrenheit,
Nope, you're finding Celsius. So you're going from Fahrenheit to Celsius.
isn't it TF?
Alright, so it's TC because you're finding Celsius. So you're
right.
going from
So-
Fahrenheit to Celsius.
So it's TC equals. There's -3, or there's plus. You add 128 to it now.
Okay, Ethan,
Come on, bro.
you have a chance to steal. It's okay, this is why we're going over them now.
9/5. Fahrenheit, Celsius, 9/5 times.
You look at your
What are you
nose.
looking at?
I have nothing in my.
Okay.
Oh crap! It is right there.
Watch your words because I don't say that.
I didn't see it right there.
Okay.
I don't know.
Okay, Lewis isn't it either, though. Alright, so for this one, you saw it as 5/9. It's the temperature of Fahrenheit minus 32 in parentheses. So that's the first one. And then I'll go ahead and tell you the other one as well. So this one's 9/5. It's the temperature of Celsius plus 32. No parentheses. So just be careful that you note these two. I know it's been a while since we've talked about them, and that's okay. Alright. What system of measurement do we use for science things specifically? Remember, there are 3 different systems of
SI.
measurement. Which one?
That's all.
Good job. I'll take that side.
What if it hits our
Say, last year students swore up and down that some of the darts were stronger than others. And I don't know. I did not.
It
Never
hit
did it.
on
I'm
the-
sorry. I'm sorry. I'm sorry. Alright. Which temperature scale is used just in the US customary system?
FPS system.
Yep.
metric system?
Nope, that's around the
Oh,
world.
no, I was answering the
But
next question.
I didn't ask that.
Hey, bro. If I missed the first one, I missed the second one.
Alright, just to make sure, do you dump acid into water or water into acid? Acid into water. You can shoot.
Oof.
Alright, Ethan, last question then. Alright, alright, thinking back over it. Oh, what is the language of science? I forgot this.
Mathematics.
Mathematics. Almost skipped that.
Is that on?
That's on it.
Yes, it is on 18.
16.
16, sorry. Alright, add up your points.
I don't even want to. He wants to.
I'm sorry, yeah, I'm pretty sure. I'm sorry. Well, next time, at least now you know. Whenever I ask, you should dip the blue dart.
I was trying to be nice.
Yeah, I didn't know. It's been too long. Alright, go ahead and take out
The red dart's
2
the-
pieces of paper, a pen. If you want to have a pencil out, you can, but you don't have to. But 2 pieces of paper, I know both of you, you're both spread out to where you probably keep cheating off each other. So just be consistent. Go ahead and have out 2 pieces of paper, so that way you get practice. Just having them out for
So
the
we have
class.
to come back after 3 weeks?
That's a question that we have to talk to them about, but you can text them and ask
Like
as
if they don't
well.
want to, can they say?
Let's keep it just related to chemistry for right now. I'll talk to you about it after class. Alright, so be sure to write your name and date at the top like you do for your homework. So name on the left side, the date on the right side. If you want to write science quiz or chemistry quiz, this is technically the second one. So if you want to write chemistry quiz 2 or just quiz 2, that's fine as well for it. Leave a blank line so that way it's neat, and then number it 1 through 10. Remember, we take our quizzes here in pen, and then if we were to grade them, we would grade them in pencil, but Corona, so we're not exchanging papers right now, which is sad. Alright, listen carefully. This first section is just straightforward, true and false. If the statement is true, simply write true. If the statement is false, simply write false. You have no clue. Guess. You have a 50-50 shot of just guessing your way through this section correctly for it. Alright, so number 1. Eye protection must be worn only when working with strong acids or bases in a chemistry lab. True or false? Eye protection must be worn only when working with strong acids or bases in a chemistry lab. Number 2. It is acceptable to carefully taste a chemical you are working with as long as the chemical is not ingested. It is acceptable to carefully taste a chemical you are working with as long as the chemical is not ingested. True or false? Number 3. Chemical odors should be tested by cupping your hand and gently wafting the odor towards your nose. True or false? Chemical odors should be tested by cupping your hand and gently wafting the odor towards your nose, not like sticking your face over it. Number 4, when diluting an acid with water, you should always pour the acid into the water rather than pouring the water into the acid. True or false? When diluting an acid with water, you should always pour the acid into the water rather than pouring the water into the acid. Number 5, unused or leftover chemicals should be carefully returned to their respective bottles after the lab is over. True or false? Unused or leftover chemicals should be carefully returned to their respective bottles after the lab is over. Number 6, all liquid chemicals may be disposed of by pouring them down the sink with plenty of water. True or false? All liquid chemicals may be disposed of by pouring them down the sink with plenty of water. Number 7, the lab instructions should be read before coming to chemistry class. True or false? The lab instructions should be read before coming to chemistry class. Alright, the next section, I'm going to ask a question, you just write off the answer for it. So number 8, what term it means, or what term do we use to refer to the language of science? What do we say is the language of science? Number 9, what is the SI unit for length? What is the SI unit for length? And then number 10, what term refers to the compactness of matter? What term refers to the compactness of matter, or how much of it is there? Alright, because this was kind of a lengthy oral quiz, does anyone need any of the questions repeated? I tried to make sure I spoke clearly and went slow enough. Okay, question number 1. Alright, eye protection must be worn only when working with strong acids or base. True or false? Alright, anyone else need anything repeated?
That question is kind of confusing.
Yeah, it is.
Okay, so eye protection must be worn only if you're working with acids and bases. That's the only time you wear eye protection. True or false? That's what it's asking.
Okay, yeah.
Okay, anyone else need anything else repeated? Alright, go ahead and give me the quiz then. We can't grade right now again because of Corona.
We'll be done with that by the class. Or, no, by
How fast do you think I can grade?
Well, stupid. No, I think you'll probably, I thought you always had an answer to check off.
No, because I do overspelling as well, and I teach a full day today. There's no period when I have a free time to be able to grade them. And since I have a very busy quiz day today, it won't be done by 2 o'clock whenever we get out. So ask your mom to check WinRep. I'll try to have the chemistry quiz done relatively fast because you're alright that it is 2, but I do have to wait, and it is dependent on how fast Jamie and Quentin get their quizzes emailed to me as well whenever I go online and post them. So I'll try to get them on today as well. But also, because of my very busy quiz schedule today, it depends. I'll try to get them done relatively soon.
We have one move issue too.
Maybe.
We do, because
Yeah, we
Maybe.
So.
Maybe. Basically told you yesterday you should be ready. So, just saying, you should be ready. Alright, go ahead and do your textbooks. Turn over to page number 9 in your textbook. We left off talking about Celsius, Fahrenheit, Celsius, and then we barely got into the Kelvin scale, but I ran out of time. So we got to finish talking about that today as well for it. Alright, so as kind of like a recap, let's finish up practicing with this. Come back. So we left talking about Celsius and Kelvin scale. No, we've already gone over your equations in the review, talking about how to solve if you're going from Celsius to Fahrenheit and Fahrenheit to Celsius. We kind of left off on the Kelvin scale. Now, the Kelvin scale is the most exact temperature scale. Now, in the United States, what temperature scale do we use? What was it? Fahrenheit. And then what do most of the other nations use? Celsius. Kelvin scale, because of how gases work, they needed a temperature scale that would get more exact. Now remember, 0 on the Celsius scale is the reference point, but what happens at 0 degrees Celsius? Freezing point of water. So that's what the Celsius scale is basically based off of. It's the freezing point and boiling point of water. So 0 degrees Celsius is the freezing point of water. 100 degrees is the boiling point of water. That's part of the reason why they did it that way, because it's convenient. Now, for the Kelvin scale, they needed us lower temperatures than that, and mathematically the Celsius scale wasn't working, so they needed a temperature scale that was more exact to work with gases. That's how they came up with the Kelvin scale. Now, the Kelvin scale, the degrees themselves are the same size as a Celsius. So that's why, since the Fahrenheit temperature degrees are smaller than the pointed the wrong one. Temperature scale for the Celsius, that's how come you have a weird conversion. For the idea of Celsius to Kelvin, their degrees are the same size. So their conversions aren't nearly as complicated for it. But their starting points are different. The Kelvin scale is based on absolute 0, or the coldest possible temperature. Your book doesn't really talk about it right now. We'll get to it a little bit later on in the year. But they wanted to base it at basically the coldest possible temperature. Whenever it's so cold, atoms stop moving, basically, is the idea over how far or how cold they wanted to get. That is an extremely cold temperature. That is negative 273.15 degrees Celsius. So since that's the starting point for Kelvin, that's the differences in between them. So that's how come for the equation, if you're going from Kelvin to Celsius, you just subtract 273.15 and that'll get your starting points back to the same way. Now if you're going from Celsius to Kelvin, instead of subtracting 273.15, what should you do? You just add it. So it's literally just the opposite for it. That's probably the reason why your book only gives you just the one equation. But just know, if I'm going from Kelvin to Celsius, subtract. If I'm going from Celsius to Kelvin, I add. Now, keep in mind, if Kelvin is based off the coldest possible temperature at 0 degrees, or 0, we don't use degrees with Kelvin, can you have a negative number on the Kelvin scale?
So that's the coldest possible.
It is the coldest possible temperature.
Ever.
Yes.
In the universe.
At this point, if you were to have a gas at this temperature, it would like condense down into nothingness. Yeah, it's supposed to be the coldest possible
Then you can't
temperature.
have negative.
Yes, so if you're working with math and you write, I have negative 15 Kelvin, you had something wrong. You should not ever get a negative number with Kelvin. So if you get this, you realize, I probably subtracted when I shouldn't have. I should add instead. Because you should never, ever, ever get a negative number with Kelvin. Alright, so let's go ahead and let's practice really quick. Either do you have your calculator today that works? Yay! Alright, so for this one, we are going from Kelvin to Celsius. So since I'm going from Kelvin, going from Kelvin to Celsius, do I add or subtract 173.15? You subtract. So keep in mind that you put the number or the quantity that you're finding by itself. So I'm going from Kelvin to Celsius. So you subtract 273.15. Let me get my answer key really quick. So if I were to start off with
649.115.
102.8.
let me get over there.
You have to subtract it negative 2.
Hey, bro.
Alright, so 300, no, 300. Okay, I'm gonna say what you did again?
I put 376 in, and I did minus negative 273.
No, you're just subtracting.
That's not wrong.
173.
So 108 point.
100 and what?
I just it's 100.
I'm like, this is just a subtraction problem. 376?
102.85.
Yes. 102.85. So this is just basic subtraction for it. Alright, the next one. 108.6 Kelvin to Celsius. Again, do you add or subtract 173 since you're going from Kelvin to Celsius? Subtract. So for this one, 108.6 divide should be
Negative.
minus
Negative
274.15.
negative 164.55.
Good job. Making sure.
Negative
Points matter.
4.55.
Let me move this over so that way Jamie and Quentin can see my numbers really quick.
Hi.
Hi, Quentin. Yeah, I think that should show up. I'm trying to write dark enough for them. Alright, so yeah, for this one, now remember, Celsius, can you have a negative number, Ethan?
No.
In Celsius?
Yes.
Yes, you can. But remember, in Kelvin, you can't have a negative number. Alright, now if I'm going from Celsius to Kelvin, do I subtract or do I add?
Add.
356.15.
You add. Alright, what's your answer again?
356.15.
Good job.
Error.
Now, keep in mind for Kelvin, we don't write the degree sign, so it's just 356.15 Kelvin. But yes, if you were to do the opposite and subtract, and you get a negative number, you know, nope, there's something wrong. I should probably go the other direction, I should probably add, because you never, ever, 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 ever get a negative number in Kelvin. Okay.
What do you have first? Like
You do
83
83.
or 273?
Alright, does it matter in addition which way you add? No. Just pick one. It doesn't matter which one you're going with. But you're just adding up the two numbers. So whatever number makes you feel better, Ethan. You will memorize 273.15 as the differences between them because of how much we use it.
Okay.
Like, you don't have to memorize it right this second, but you will just because of how much we use these numbers. Alright, anyone have any questions about that? Okay, I think we have time. So the red numbers, this one is kind of like, this is kind of like an advanced level problem. So if I'm going from 314 degrees Fahrenheit to Kelvin, what should I do?
You have to go to Celsius first and then go to Kelvin.
And then you go to Kelvin. Alright, so this one's a harder one. That's why I made it red. This is like the boss level, basically. Alright, if I'm going from Fahrenheit to Celsius, what equation do I use?
P equals MV.
No, use the 9 over 5.
What's it be like, Ethan?
You do the
TF equals 9 fifths, T6
This?
equals 32, yeah.
This one, if you're going from Fahrenheit to Celsius.
Yes.
Which one's by itself? So
The
if I'm
other- I was talking about the other one.
Alright, so this one, this, it's 5 over 9. Now remember, it's the Fahrenheit temperature minus 32 first, and then multiply and divide it. So first off, what's your answer in Celsius first, before you start any other conversions?
156.7.66.
Yeah, we'll leave it unrounded for right now. So 156.66. If we round now, we might get a slightly wrong answer. So it's better if it's better if you wait till later.
I got.
Wait. Let's pause a second. Alright, Ethan, you can go ahead and solve it if you want to.
I already
I
did.
just want to make sure. Okay. Okay, you got it? Alright, now since I'm going from Celsius to Kelvin, do I add or do I subtract? You add. So add it together.
429.82.
Good job.
I rounded.
That's fine. Alright, so
Nice,
anyone have any questions about how to solve this? So, anyone have any questions about temperature scales? Because I'm telling you, these are the first set of math equations that you need to know for chemistry. So not only the terms and definitions, you need to know how to solve. So if you were to get like a problem on a quiz or test that says what's the density, or if I start with Celsius, how do I go to Fahrenheit? Solve it. You're going to start getting those on your test where you have terms and definitions, and then you flip the page, or further down the page, you're going to have problem solving sections where it's solve the math. So anyone have any questions about the math? We'll move on.
You saying we're gonna have that on our next quiz?
I can't tell you for sure right now, but on the test, absolutely.
And that's in like 2 weeks.
But by then we'll have memorized it.
So,
Yeah, but I mean, still work on
Is it
memorizing
next
them.
week?
2 weeks.
For chemistry, no.
Is it 2 weeks?
I was about to say,
So
what?
and by then, just the amount we do in class will memorize those formulas without even having to study, right?
You used to say it because this is the reason why I've been over practice so much, because I have to move on. So I'm not going to keep doing temperature problems every single day. Like this is pretty much the last day for me, and then I have to go. Right before the test, we'll do kind of like a recap. But I'm not going over how to solve these math problems every single day. I might ask you for like a formula, like what's the formula for density, mass over volume. But I can't keep drilling how to solve this, so you gotta study on your own for me. Okay, so getting into it, so page 9 really quick, other SI units, to make sure that the second, that this is the SI unit for time. Now, you can typically convert to minutes, but since in a lot of cases we're working with chemical reactions, how fast they occur, typically seconds is a good one to use for it. Alright, really quick.
Are we done with the calculator?
For right now, yes.
Today?
No. But for right now, yes.
Scientific innovation.
Yep. So I'm going to talk about dimensional analysis too as well. Your book gives you several other units. You don't have to know them right now. You may not know that the second is the SI unit for time. So make a note for that. Alright, now next page. Dimensional analysis. This is a conversion factor or a way to go from one type of unit to another. We use this over and over and over again in chemistry. This is super important that we get practice with it now. So to perform unit conversion, you should use the technique of dimensional analysis. Your book tries to describe it to you in words, but it's so much simpler just to see it done on paper. So let's go ahead and let's look at the example first for it. Now this one is a basic one. It's asking you how many minutes are in exactly 2 weeks. So you're going from minutes to 2 weeks. So you're supposed to figure out, okay, how would I do this? Now you might figure out, okay, I know how to do this in my head, but let's go through and let's solve how you set this up, because you use this technique over and over again in chemistry, and this is just the starting ones. Now, how you use dimensional analysis is you're going to draw a line, and this is basically a giant fraction bar, and it'll help you to see, do I multiply or do I divide? Now, whatever you're starting with, that is what you put in the top numerator one. Now for this one, the question is asking how many minutes are in 2 weeks. So what am I starting with? Weeks or minutes? What do I know right now? What number am I given? What?
2
2 what?
weeks.
2 weeks. So I'm going, even though it's asking me how many minutes are in 2 weeks, I don't know how many minutes are in 2 weeks. So I'm starting with 2 weeks and I'm trying to find minutes. So I put 2 weeks, I'm just gonna write WK because I don't want to write weeks fully over and over again. So 2 weeks goes in the top part right off the bat. Now, does anyone know how many minutes are in 1 week? Just off the top of your head.
I know how many minutes are in a day.
Alright,
We just
well,
by 14.
by 14.
Yeah, that's how many days are in 2 weeks.
Okay, you could do it that way a little bit. Let's break it down a little bit smaller. You know how many minutes are in a day for sure? Okay, let's break it down a little bit smaller so I can go back a little bit.
1,440.
Cool. Alright, well, if I'm going to go from a week to a smaller unit, what would be the next time unit I would probably jump to?
Probably a week.
Okay, what's the, if I want to go smaller, so what would be the next unit I would go down to?
Okay.
Day. So, now, keep in mind for this one, you want to keep the units in the numerator, and the next part of the dimensional analysis, you want to put it in the denominator, because remember, units cancel out if they're in the top and bottom, so you're kind of going like at a diagonal, going across. So if I have 1 week, how many days are in 1 week? Did you just say 2? Okay, 7. No, you're right. 7 days are in 1 week. Okay, what's the next small unit I would want to go down to?
Probably hours.
Yeah, hours for it. So, if I were to have 1 day, how many hours are in 1 day? 24 hours.
Minutes, next.
Yep. So, what was in the bottom down here then?
24 hours.
Yeah. Well, here's 24 hours.
1 hours.
Yeah, so 1 hour will equal how many?
60.
1,440. Oh, 1 hour.
60 minutes.
Yeah, you could do it 60 minutes. That works. Or if you want to know and just convert it in your head, you can. That's fine. But we'll just keep going down smaller. So then 1 minute, and then run out of room, equals how many seconds? 60. Alright, this is how you know, okay, well, I forgot. It's only asking me how many minutes. I forgot later on it asks for seconds. So, since this up here is ending with minutes, that's where we can stop, because that's where I have to find for it. So this tells me, okay, this is all of my conversions. You should always have a 1 in the top or bottom, because you're converting basically from one whole unit into the next smaller one. Occasionally you can jump, but for right now we're just going to keep it really consistent. But the important thing is you want to keep, if you have one type of unit in the top, the next denominator close to it should have the exact same unit, so that your units are constantly canceling out as you move across, and you're left with the final unit that you need. Now, if you're working with a fraction, do you multiply or divide everything at the top?
In the top, everything else that's on top, what you do is you
Multiply.
Yes. So you multiply everything at the top. So for this one, it would be 2 times 7. Now everything in the bottom, what do you do with in the denominator?
You just drop it.
Okay, yes, because these are all ones, you could just drop them. Now, if I had a number like 2 down here, what would I do with the 2? Divide. But you're right, since these are all ones, you can just forget that these exist down here. So it would be 2 times 7 times 24 times 60, alright, which is what, Chris? Oh, I thought you were done, right? Okay, so we'll pretend to first. Okay, Ethan, you done?
It's 220.
Wait, I already told Ethan, so hang on, let's give him 5 seconds, sorry.
Nope.
20,160.
Good job. So for this one, it's did you just look in the book?
He did.
No, I
Okay,
didn't.
just
No, I
making
didn't.
sure.
I
You're
did
not invited to my birthday party.
Alright, so 20,116 minutes. Alright, so that's just the one your book gives that as an example. Okay.
If say upon our quiz test you give us a problem that we need to do this, we don't set up that graph is wrong.
Sorry, one more time.
If you give us a problem like that where we have to find that using the
Dimensional analysis?
Yeah. If we don't set up that graph, do it a different way, are you gonna crucify us and take off points?
Okay, so keep in mind, like for math problems, if you just write 16.0 and your 16.0 is wrong, what happens to all the partial credit for the math? You don't get any of it. So just like the same idea, if you just write out your answer and it's right, okay, technically you're right, unless I tell you that I need to check something to show it, but it's always better to show it,
Yeah.
so that way I know, what did he do? There was one student one year who never showed his work ever. A lot of your math problems are worth 3 points, or 5
On
points,
test?
or 6 points, yeah, because of how hard they are. So since he
Hard.
didn't show me the work, all of the points would be lost for that particular math problem.
My brain just doesn't think like how you did it there. My brain isn't that organized, I should say, or isn't that like, I don't
It's
think
okay.
of it like that. Like, I would get 1440 and that times it by 14, because that seems easier, it's quicker.
1440, that's how many minutes are in a day?
I would just times
Okay,
it by 14.
but you already memorized that already, or how did you figure out there was 1440?
I didn't know.
Okay, so you did the math basically, but you just didn't organize it this way. Now, the first reason why we practice is because there are some formulas or some problems that you use this with because you're going from one type of substance, its weight, to another one. And if you don't know how to set it up like this, you're gonna get really stuck. So it's kind of like in algebra, how they give you the super easy ones first, and then they let you above it, and then they work you out the harder ones. Same idea. Let's do some more practices, just so that way it'll help you out. So look on page 10, the application. Oh, let's do C and D, so that way, I'm sorry, you can do practice one. You'll probably do A and B for homework tonight.
C and D?
Yeah, C and D.
Where's that at?
On bottom of page 10, application number 4.
Oh.
C and D. Alright, I'm gonna tell you right now, D is crazy hard, so I'll help you with that one. That one's the most complicated one. Let's do number C for that one first off. Alright, so, let me get over there.
What's the conversion from milligram to grams? Is it 100, right?
If you're going from grams to milligrams. Alright, so what are you starting off with? Grams or milligrams? What do you know?
We know that the grams.
Yep, so you know how many grams there are. So you're going from grams to milligrams. So what goes in the top? The grams or the milligrams?
The grams.
The grams. So for this one,
I just don't know the conversion rate.
we'll talk about it.
Is it 16?
0.00590. I should have left more room for myself. Alright, so if you have milli of a substance, do you remember what milli means? 1,000 or thousand?
1,000.
Thousand. So how many milligrams are in a gram then? 1,000. So I'm starting off with 1 gram. So sorry, I'm starting off with point this of a gram. So what goes in the bottom down here, grams or milligrams? What?
Milligram.
Alright, what unit is this?
Gram.
So what goes down here? So the units cancel. If I'm starting with grams and the numerator, I need to cancel out
Grams.
grams. Yes. So 1 gram has how many milligrams?
1 gram has 1,000 milligrams.
Hmm?
But this is an easy problem because you can just do it by looking at it.
Yeah, but you didn't know your conversions. This is one reason why you have to know your conversions for it. Alright, so multiply 1,000 times. Oh, let me get over there. I hurry to get over for the next one, but the next one's harder.
5.9.
0.
Okay, so it is what then? Yep, 5.9. Talk about 6 later on. So 5.9 milligrams for it. So again, just practice over. What'd you say? Good job. Over how to solve. Alright, the next one is harder. So go ahead and look at that one, and let's talk through how you would solve this particular one for it. So for this one, you are converting 5.0 centimeters per second to kilometers or kilometers per hour. So there are 2 things you're working with. Not only are you changing the length, you're changing the seconds. That's why this one's a little bit harder. You're not going to have something this complicated on quizzes and tests. This is just like the hardest thing you can come up with. Alright, so what am am I starting with? What do I know? Centimeters or kilometers? Centimeters.
Yeah, centimeters. I was saying that.
There's-
Oh, shit, fine. Yeah.
Isn't there like 1,000 centimeters? No, there's way more than 1,000 centimeters in a kilometer, right?
Yeah.
It's like 10,000.
Okay, let's do it in smaller units. You don't have to memorize how
No,
many
I just wanna
centimeters.
know.
Alright, I don't know either off the top of my head because I convert it into smaller, like I convert it into the next step. So don't try to like over jump yourself. It's okay to run all your steps. It's fine. Alright, so I'm starting off with 1.5 centimeters per 1 second. So I'm just gonna write this down here. We're not gonna worry about the second check. I'm just gonna leave them alone. So I'm just gonna draw a line so I can go all the way across for it.
Good.
Alright, it's gonna be a long one. Alright, so if I'm going from centimeters to kilometers, what is probably the next largest unit I would probably jump to?
Meter.
Meter.
Meter. I was gonna say that.
Alright, so centimeters is in the numerator, so what unit goes down here?
Centimeters.
cm.
Centimeters. So how many centimeters are in 1 meter?
100.
It's not.
100.
Did you say 700?
No, 100.
Okay.
100.
Alright, so meters, I can probably jump from meters to kilometers. So how many meters are in a kilometer?
1,000
1,000. Now what goes down here? Meters or meters or kilometers?
kilometers. Meters. I was saying that.
Yeah, so 1,000 meters are in 1 kilometer. So keep in mind you have units down here. That's really messy thousand. Alright, so keep in mind you have units down here, so we're gonna have to divide. Okay, so I'm ending with kilometers up here. That's where I have to end, but I have to change over my seconds now. Alright, seconds is in the bottom. So if I'm going to convert from seconds to probably minutes as the next easier one, where do I put the second units then, on the top or the bottom as well? I put it on the top because you have to cancel them out. So remember, it's the same idea. If I have it in the bottom, I have to have it in the top later on to cancel. So how many seconds are in a minute?
60.
60. So 60 seconds are in 1 minute. So if minutes are in the bottom, what goes in the top up here then? Minute. Because remember, the same units have to be diagonally across each other.
Oh,
Now
yeah.
keep in mind, there's a big gap, but because we're jumping from length to time, they can be that far apart. So if I have minutes and I'm going to hour, how many minutes are in an hour?
60.
60. That's why this one's a little bit complicated because you're gonna have to divide and multiply. I'm gonna draw a line so I don't forget about my formulas that are down here. Okay, so for this one, does it matter with multiplication and division when you multiply and then you divide?
No.
No. So it makes you feel better to do 1.5 divided by 100 divided by 1,000 times 60
1.5.
times. Because that's what you started with. You started with 1.5 centimeters.
So 5.05 times.
Oh, I'm sorry. That's what I flipped the decimal, didn't I? Sorry. 5.0 or 5.0. I accidentally moved the decimal point in my head. Alright, so 5 or 5.0 divided by 100 divided by 1,000 times 60 times 60. If you want to multiply the whole top and then divide by the whole bottom, that's fine. Whichever way works for you.
0.18.
Wait. See if you can catch up.
Equals. Yeah. Okay.
Okay, what'd you get, Ethan? And then I'll check your answer based on what Ethan says.
For what we just did with dividing and multiplying.
Yes, the whole thing.
Oh, the whole.
Okay, so 5.
Yeah. Okay. Is it 0.003? I think I didn't multiply 60 twice.
Okay,
Can I do it? Alright.
let's give it one more chance.
Going all the way here.
5 divided by 100 divided by 1,000 times 60 times 60.
Times 60 is 0.18.
Alright, what'd you get? Alright, so 0.18 kilometers per hour. So that's the product for it. Alright, so does anyone have any questions about how to set this up?
Not that hard.
Okay, yeah, so it's one of those. Once you get practice with it, it's okay. But it's one of those. Sometimes just getting it organized and sometimes organizing your thoughts to be able to do it this way is a little bit complicated. But trust me, you'll want to because later on you're doing a bunch of other conversions and they're not going to be this simple. That's the reason why you want practice. Even though I know you can probably do it in your head, you still want practice for it. Alright, now you have time to do anything else. Alright, your practice for your homework for tonight.
Hold up.
Hurry, get homework.
Hold
Oh wait, this class ends in 5 more minutes. I do have time.
Well, can we give you
I
a
lied.
little?
I lied.
I already have my homework.
I'm like, I'm sorry. I forgot.
How
Alright,
dare you.
mathematics and chemistry. Alright, so scientific notation. Alright, if I about on page 11. For example, the number of carbon atoms in 12 grams of carbon 12 is roughly 602.200.00000000000. That is a huge number. No one wants to read that number out loud or say that large of a number over. I actually don't know. That's up there in like,
It's quintillion.
it's way up there. So no one wants to
Quintillion?
talk about it.
Quintillion. Quintio.
Alright, back on. Alright, the mass of the electron, your book points out as well, is 0.000000000000000000000000000000000000000000009 grams. Again, an incredibly small number. No one wants to write that over and over and over again, and no one wants to try to say that with words over and over again. The scientists go, there should be a much easier way to do this. We want to come up with in a much easier fashion. So they come up with scientific notation. It's a way to express really large or really small numbers between 1 and 10, and because it's multiplied by 10 with an exponent. So this is just a way for scientists to convert these really large numbers into much smaller numbers for you to be able to say them easier, plus plus the ability to be able to write them out and not mess them up is greatly hindered if you're using a scientific method. It's a lot easier for it. Alright, the exponent corresponds to the number of places the decimal point must be moved to the left in order to have one digit between remaining to the left of the decimal point. Mark that last sentence on this first full paragraph. It's not bold or italicized, but it tells you basically how to do it. So the exponent corresponds to the number of places the decimal point must be moved to the left in order to have only one digit remaining on the left side of the decimal point. Between 1 and 10 on that side. That's probably the reason as to how come you're moving your decimal point to figure out, okay, I want to do this in a much smaller number between 1 and 10. So what's the number between 1 and 10?
6.911.
Alright, so is 6.9 is the 6 between 1 and 10?
Yes.
Yes, so if I were to just write it as 69, is that between 1 and 10? No, so you would have to move the decimal points again for it. Now if you were to have 0.69, is this between 1 and 10?
Yes. No, it's not. It's before 1. It's before 1.
Yeah, it's lower than 1. So it has to be between 1 and 10 for it. Alright, mark the context sentence at the top of the next page as well. So 11. The exponent in scientific notation is the number of places the decimal point must be moved for the first factor between 1 and 10. Alright, your book gives you several examples for this one. So if I were to have 6,020,000. Now the decimal point is understood to be right here. So if I need to get this number to have the first digit between 1 and 10, how many times do I have to move the decimal point? Alright, this? 6. So you move it 1, 2, 3, 4, 5, 6. So that'd be 6.02. If you put a second zero, you're not wrong. Most people don't. So 6.02 times 10 to the positive 6 because you moved the decimal point 6 times. So the exponent is telling you how many times you moved it. If you have a really small number, like for example, 0.00031. You sure Jamie can still see me? Yes, they can. Alright, so let's see how many times do I move this decimal point to get it between 1 and 10? Ethan.
3 times.
2, 3?
4.
4. It's okay. That's why you count 4. So 3.1 times 10 to the negative 4. We use positives and negatives to tell is this a really large number or a really small number. So since I went from the left to the right, or I started with a small number, we use the negative exponent. That's how scientists are telling each other it's a really small number. If it's a positive exponent, that means you started off as a really large number, and you moved it to the left. You don't have to memorize it as you're moving it to the left or to the right. Sometimes students do. You just make a note of, okay, if I have a 6, and it's just a 6, a positive number, then this should be a large number. So if I have to take it out of scientific notation and put it back in regular form, if I move this direction with the decimal point, will my number be getting larger or smaller?
Bigger.
If I move the decimal point like this?
Yes, now I see, yeah.
Alright, so it's getting
I was looking
small.
at the 6 million.
Yeah, no, it's okay. So that's probably the reason why. If you realize, I have a positive exponent. Oh, no, I'm not done. Alright, we'll stop there. You ready for tonight? Alright, practice on application on page 10. Do number 4, A and B. So just A and B on number 4. And then also, let me get over to the
Page 10, application.
4, A and B. Also, read pages, oh, I forgot to check your homework. Show me your homework in a minute too. Read pages 17 to 19. 17 to 19. Answer on page 23, the concept review 1 and 2. So answer on page 23, concept review 1 and 2. Alright, show me your homework really quick. I know I forgot. Thank you. There you go.